Uh, we just learned all about row operations and elimination, in particular Gaussian elimination, Gauss-Jordan elimination, and all those echelon forms, including reduced row echelon form. We now have a way to calculate an inverse. This was something that we left for later when we covered matrix arithmetic. Now we've got a method. First, we'll augment the matrix A. And now this, remember, the inverse only works on square matrices. So if A is a square matrix, we can try this. First, we'll augment it with the whole identity matrix itself. So here in parentheses is the augmented matrix. It's the A part on the left and the identity on the right. Same size matrices. Then we're going to do Gauss-Jordan elimination, which really means we multiply this guy by some E, which is a matrix multiplication that's equivalent to all the row operations. By block multiplication, multiplying this whole matrix is the same as I'll treat E as a block and A as a block and I as a block. I get this. EA on the left side, EI on the right, and EI is just E. Now, what if, when I did the Gauss-Jordan elimination, the EA turns out to be the identity matrix? So that I have an I here. If EA equals the identity, that means E equals A inverse. Here it's on the left side, but it works on the right side, and it's unique. So that on the resulting right side, if I get the identity on the left, the resulting right side after Gauss-Jordan elimination is the inverse of A. Like in this example, here's the A, here's the augmented matrix. I put the whole identity matrix to the right. I start doing row operations. I get to here and look at this. All I did was Gauss-Jordan elimination. 2 pivots, no all 0 rows. There's a 1, there's a 1. The pivots are 1, and everything else in the pivot column is 0. The thing here on the left is in reduced row echelon form. Well, the whole matrix is in reduced row echelon form. And the part on the left is the identity matrix. Everything follows as I said it from up here, which means this right side is the inverse. Well, because I got the identity on the left, that tells us it's invertible. And the right side tells us what the inverse is. It is invertible, and here's the inverse. I'm not saying this is the best way to calculate an inverse, but now we have a way, which means we kind of have a complete arithmetic repertoire. Anyway, now that we know all about elimination,